Hello everyone, my name is Basil and I'm presenting my project Performance of Aphron Drilling Fluid in Depleted Reservoir. Uh, as a brief introduction, most oil and gas reserves are ancient and hydrocarbons are rapidly produced, making drilling operation even more expensive, while the formation on top and below this production area usually have much greater pore pressure and need high fluid density to minimize them. Exposure to high density for a depleted reservoir can result in significant loss of entire drilling fluid and differential sticking. So, as a solution for this, high performance Aphron drilling fluid comes to be used as an underground drilling, as it's increasingly on demand for drilling depleted and multiple zone, where the fluid has a density that is small enough to suit the lower pressure area of the formation. Drilling with Aphron is without such limit. Usually the area used to produce Aphron is mixed with the traditional mud mixing equipment in the fluid at ambient pressure, uh, reducing the cost and safety concerns associated with air or foam drilling. The aim and objective of this project is to evaluate the stability of Aphron drilling fluid in depleted and multi-zone formation. The objective is to appraise the performance of Aphron drilling fluid as an invasion control system in drilling operation, to formulate high-performance Aphron drilling fluid for depleted and multi-zone formation, and to come up with a drilling fluid uh, which can save cost and time. The research problem was to minimize the fluid loss control and invasion rate in the depleted formation by optimizing the formulation of Aphron drilling fluid to obtain the highest performance, as well as minimizing stack pipe, which a problem occur frequently in the depleted formation. During drilling operation, the size of Aphron should be in accordance with the bore size distribution of the formation for an effective sealing of formation bores. The photo provided by system microscope demonstrate the generation of high performance Aphron microbubbles. The bubble size has a significant effect on the stability of Aphron. Larger Aphron can survive for longer than the small ones. When the diameter of Aphron is smaller than 50 micron, they are less stable. Therefore, more Aphron with diameters in the range of 50 to 100 micron were expected uh, for higher stability in the downhole formation. The problem being solved after modification and evaluation of the standard and enhanced Aphron drilling fluid to obtain high performance drilling fluid with a light density and high low shear rate viscosity that can control high fluid loss and lower invasion rate. As you see in the photo, this is the function of Aphron drilling fluid. During the drilling, Aphron work under differential pressure, so it goes into the formation to plug the microfractures and vugs in the depleted formation till the drilling operation finished. Then it release itself up to the annulus and go up to the surface. One of the factors I considered in the modification of Aphron drilling formulation by increasing the surfactant concentration uh, up to certain limit, because I don't want my high performance drilling fluid to have a high concentration of surfactant that it be residual in the downhole formation, as Aphron clean uh, clean itself by itself and by the function of differential pressure. So if there is a much concentration or high concentration of surfactant, it might be residual and stay downhole. This is considered as novelty and innovation. Uh, Quality of the drilling fluid and the high performance Aphron is determined based on the increase or decrease that have been done to the density, viscosity, fluid loss, and mud cake in addition to gel strength and demonstration of the newly developed drilling fluid. Uh, as it's the most suitable to the bed reservoir and multi-zone formation. As a commercial potential, the economic impact will be reflected on the industry through the main benefit of the drilling fluid system, which is able to minimize low circulation. It's very beneficial to well productivity, primary cementing, and provide the means to drill through low pressure formation, which is the depleted reservoir. This wells searching for productive zones for oil will exhibit high performance, uh, faster response after initial simulation. The quick response to the due to the high performance Aphron drilling fluid is due to the fact that the microenvironment consists not of filtrate, water, or solid packed well cake, but its system containing mostly air and gas with small concentration of surfactant and polymer, as it's very useful to industrial application in the drilling operation. As a sustainable development, using high performance Aphron drilling fluid will minimize the skin factor, which is the damage caused by the drilling fluid to the downhole formation, uh, which can be treated by acidizing or fracturing. Acidizer and fracturing can be migrated to the water aquifers and disturb the life and disturb the surrounding life species. So it's very beneficial to the sustainable development, as it minimizes the need of acidizing and fracturing, which have some risk, and Aphron high performance Aphron drilling fluid can minimize it, as the contamination of groundwater, methane pollution and its impact on climate change, air pollution impact, exposure to toxic chemicals, blowout due to gas explosion, uh, waste disposal, as well as large volume water use in water deficient region, fracking, including earthquake, workplace safety issues, infrastructure degradation, and serious impact as air pollution, soil and oil spill contamination, regardless of health effect. This was summary of my project findings.